Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Four Slow Thermos by Mello Robinson. And here are the rules. We have normal chaos construction rules apply, which means divide the grid into 9 regions of 9 orthogonally connected cells, and fill every cell with a digit from 1 through 9 so that there aren't repeats in a row, column, or region. And what is an orthogonally connected region? It's basically a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So for example, to get from here to here, you can go along these edges, all while staying within the region, which is why it makes this a valid orthogonally connected region. This is an example of an invalid orthogonally connected region because even though these two cells can get to each other by going through edges while staying within the region, they can't get to the other cells in the region by doing so. They either have to go through a corner here or go through an edge and exit the region before they can get to the other cells, which is neither of which is allowed for orthogonally connected regions. So that's how chaos construction rule sets work. We also have slow thermometers, where along a gray line, digits must not decrease, moving away from the bulb end. Additionally, two cells connected orthogonally, which means horizontally or vertically, by a thermometer line must be in the same region. And diagonal constructions have no additional restrictions. So these cells must all be in the same region. These two cells are orthogonally connected by the thermometer line, so they must be in the same region, as must these two. So as an example, what we could have something like, say, we could have something like, say, it's not clicking on things. 2, 2, 4, and 8. And this would be valid because this thermometer is not decreasing in a lot from going from the bulb to the tip. What would not be valid is something like, say, 2, 1, 4, 8, because it's decreasing from this cell to this cell, which is not allowed. And in addition, we know all three of these cells must be in the same region because they are all connected orthogonally, which just means that they share an edge by a thermometer line. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so let's draw edges of lines. Let's do the whole boundary. And anywhere that two cells are connected orthogonally by a thermometer line must be in the same region. So this is the same region, and this is the same region. Same with this, and that. Same with these two. Same with these 3 cells. Same with these 3 cells. These 3 cells, and these are the same region. These 3 are the same region. These 3 are the same region, and these 3 are the same region, as are these 3. That's the same as that, which must be the same as that, which is the same as that, same as that. So we have 1, 2, 3, 4, 5, 6 cells here. That must be in the same region. These are 1, 2, 3, 4, 5, 6 cells that are all part of the same region. So this cell must be part of that region. So we know that that's those cells there. These two are in the same region. This is the longest region. Let's go, or longest thermometer. Let's go along this. What is the minimum for each set? This can be 1, because that's the smallest digit in a normal Sudoku. This could be 1, because they are not in the same row or column. This could be 2, because they have to be in the same column. This has to be 3, because they have to be in the same column. This could be 3, 4, 5, 5, 6, 7, 7, 8, 9. And therefore, these have to be those digits. So this must be, we have 9, 8, 7, 7, 6, 5, 5, 4, 3, and 3, 2, 1 here. And that's 1 there. What about minimums here? This is 2 at minimum, because it can't be 1 because of 1 in the row. This is smaller, greater than that, because they're in the same column. Cannot be 3, because of 3 in the column. So it could be 4. This is greater than that. Cannot be 5, because of 5 in the row. So this is at least 6. This must be greater than 6, so 7, 8, and that must be 9. And because of the way that this works, then this must be 9. We have to have 9, 9, 8, 7, 6, 4, and 2. These are all the same region. So we'll mark that as pink. They cannot be the same region as 5, 6, and 7, or 5, 4, and 3, or 3, 2, and 1, or 8, 9. How is this going to work? We need a 1, a 3, and a 5. Two cells connected orthogonally must be in the same region. Oh. I see. Hold up. Okay. So we know these do have to be 9876 because there's no other possibility here. But this has to be less than 6, so it could be 4 or 5, and this must be less than 5, so it's 2, 3, or 4. There we go. So we know this cannot be this. These are different regions because 7, 8, and 9 are the same region. We have 6, 7, 8, 9 here, so these have to be different regions. And we have a 4, 5 here in this cell here. This can't be 3. So therefore, these have to be different regions, because we have a guaranteed 4 or 5 here, and this contains a 4 or 5 in the same region. So to exit out, this also cannot go this way, and this is a different region than this. This is a different region than that. Oh, we don't know. This has to go out this way because it's blocked by the pink. So this must go this way. Therefore, this is not valid as a region. So this pink has to exit out here. So it must be part of that as a region. So that's done as a region then. This must be then all pink. And this must be part of yellow. Or maybe we can make it... It cannot... It has to be green, actually. So this cannot be part of the same region as the 7, 8, 9, because we already have a 9. So then this must go out as a region this way. So this is all green. This can't be 2 because of 2 in the region, so this is 4 and 5. Remaining digits in the green region have to be 1, 2, 3, 4, and 8. No 1, 4, or 8 here because of 1, 4 in the row, 8 in the column. No 8 or 2 here because of 2 in the row, or 4 because 4 in the column and 8 in the column and 2 in the row. So this is 7, 8, and 9. Remaining digits of row 4, we have 1, 2, 8, and 9. No, 1, 2, 4, and 9. So no 1 here. This digit is less than 1, 2, 3, 4, 5 cells, so it cannot be 9. This is digits less than 3 cells, so this can't be 9. So let's go along with this. 2 at minimum. This could be 2 also. It cannot be 3 because of 3 in the row, so this has to be greater than 2, so it's at least 6, at least 7. This is 9 at most. This is less than that because it's in the same row. Less than that, 7. So it could be 2, 6, or 7 there. This is 2 or 4 there. This is 6, 7, 8, 7, 8, and 9 there. Let's go along here. We can have 2, 3, because they are in the same column, 4. And this is at most 6. Cannot be 6 or 5 because of 5 or 6 in the column. So this must be 4 here, which makes this 3, which makes that a 2. This can't be 2 anymore. It's 3, which means this can't be 3. That's 1. These are all in the same region, but we already have a 3 here. So this cannot be in the same region as that. We'll mark this as red. 2 eliminates 2 in the rest of the column. This digit must be smaller than this because they're the same column. 2, 3, 4, 5, and 6. It cannot be 6 or 7, so this is at least 8. This is at most 9, at most 8, at most 7, at most 6, 5. So this cannot be 3, 4, 5 here, which means this has to be a 2. So this is 2, and this has to be 1. That eliminates 1 in the rest of the row. 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, and this is 8 or 9 here. Okay. 2 eliminates 2 here. This digit must be greater than that, so no 6, no 7 there. Remaining digits of row 3 are 1, 6, 7, 8, 9. No 6, 7 here because of 6, 7 in the column. Remaining digits. This could be 1. This could be 1. This could be 2 because it's in the same row. This cannot be 3 because of 3 in the column, so it's 4. So 4 through 9 there. This is less than that, so it's 8 at most. But it could be 2, 3, and 8. No 4, 5, 6, 7, 8. This has to be less than that, so it's 7. It cannot be 7 because of 7 in the column. So it could be 6. 1, 2, 4, and 6. This must be at least the same, so it can't be 6 here because of 6 in the column. So this is 1, 2, or 3. This thermometer, we can have 1 here, 2, and 3, and those are possible. This cannot be 9, 8, 7, so it's 6 at most. This is less than that, 5 at most, 4 at most. It cannot be 4 or 3. Therefore, this is 1 and 2. This is 2, 3, 4, 5. No 4 because of 4 in the column. 3, 5, and 6 as possibilities. Okay, remaining digits. Let's go here. No 1 here. 2. This can't be 3, 1, 2, or 3 because of 1, 2, 3 in the column. So 4 at minimum. 5 at minimum. 9 at most. 8 at most. 7 at most. Because they are all in the same region. This can't be 8, because if this is 8, that becomes 9, and that would eliminate all possibilities for that cell there. So no 8 and no 7 there. Remaining digits of row 6. We have 2, 5, and 6 left. This can't be 2 because of 2 in the column. This can't be 2 because of 2 in the column. So where's the 2 in row 7? It has to be here. 2 eliminates 2 there. Where's the 2 in row 4? It has to be here. So that's 2. Okay, remaining digits of column 4. We have 1, 2, 4, 6. Remaining digits of column 5. We have 2, 3, 5, 6. Remaining digits of column 6. We have 1, 2, 7, 8. Hmm. Remaining digits of column 3. 1, 2, 3, 8, 9. Remaining digits of column 6, 4 through 9. Remaining digits of column 5. We have 3, 4, 7, 8. No 3 here because of 3 in the column. Row 6, we have 5, 6, and 8. Hmm. Okay. Remaining digits here can be 3 through 9. Column 8 are 3 through 9. This can't be 2 because of 2 in the column. Okay. Hmm. Um, One has to be one of these 2 digits here in row 4. Sorry, row 3. Hmm. Green needs access to a 2. And it can only go 3 cells. So it's not going to access that. It has to go this way. So green has to go this way there to access a 2. And one of these is going... This can't be 8 or 9 because of 8 or 9... Sorry, 1 or 9 because of 1 or 9 in the region. So that's 8. That eliminates 8 here, so that's 9. No 8 here, it's 7. No 7 here, it's 6. That leaves this as 1. No 1, 3, 8, or 9 here, so that's 2. 8 eliminates 8 here, so that's 9. So no 2 and 8 here, because of 2 and 8 in the column, so this is 3. That means this can't be 2 or 3, it's 1. So this is less than 3. So this cannot be 4 or 6. 2 eliminates 2 in the rest of this row. And we need access to a 4 for red, or for green. So it's one of these. But this has to exit out. So actually, let's make this... Oof. Yeah, that's fine. That's green. we cannot go 4 here or 4 here because that blocks this one from getting out as a region. This is probably going to be red. So then green needs access to a 4. It must get 4 there. So that's 4. That's done as a region. No more 4 in this row here. No 4 here. No 4 here or here. No 1 in the rest of row 9. This cannot go to the same region as this because that's already 1, 2, 3, 4, 5, 6, 7. And 7 plus 3 is too many cells, so this is gray. Can this ever not be part of the same region here? I guess we could have 9 going that way. That is possible. Realistically, we don't actually know if that's the same. Oh, this has to exit out. If this tries to go, is not part of the red region. The problem with that is it has to go out this way then. But then this is 1, 2, 3, 4, 5, 6, 7, 8 cells in that region when it's supposed to be 9. So this must be part of red. So 4 eliminates 4 here in the rest of the red region. So that's 9, which makes this 4. This can't be 4 anymore. It's 7 or 8. We have to have one of these at least be light. So this is light there. 3 is not part of this region because we already have a 3. This can't be part of the region because that's 7, 8, and 9. We already have a 9 in that region. So we have boundary there. So red has to go out. We have to have 1, 2, 3, 4, 5, 6. We have to go at least 7 here, 8 here, and this could be 9. So this is light or medium there. This is light or medium there. Actually, we have 1, 2, 3, 4, 5, 6, 7, 8. Right, so one of these two, this can't be medium. This is light or red there. And this could be this is guaranteed to have all red there. 9 eliminates 9 in the rest of the light region and row. This is part of a different region. We'll mark that as yellow. This could be 6, 2, and 1 here. That is possible. Nine eliminates 9 of the rest of the column here. So 4 has to be one of these two digits here. In column 2. That leaves us as 4 through 8. Remaining digits of column 1 are 3 through 9. And no 3, 4, or 9 here because they are in the red region, guaranteed. Okay. Three eliminates 3 in the rest of this row. This digit can be 1. Has to be at least 3 here. No, 9. So it's 8 at most, 7 at most. So it could be 1, 3, 5, 7 here, because it can't be 2, 4, or 6, because it's 2, 4, 6 in the column. We could have 3, 5, 7, or 8 here as possibilities. 4 in the light region cannot be any of these cells here. So 4 has to be one of these two cells here, which eliminates 4 in the rest of the column. So this can't be 4. We know these are boundaries. Okay, so these we can get rid of. Um, 9 eliminates 9 of the rest of column 7. Where is 9 in row 2? Can't be in the light region, can't be in these cells here because of 9's in the column. Can't be here, so it must be here. That eliminates 9 in the rest of the column here. So these are part of two different regions. So we have a definite boundary here because we have a 9 in this region and a 9 here. Um, Interesting. Seven eliminates 7 in the rest of column 8. Remaining digits here have to be 1, 3, 5, 7, 8, and 9. No 3 here, no 1 here because of digits in the rows. Okay. Um, this cannot be part of both of these regions. Because then this would not be a valid region. It would be too small. It could be part of this region, in which case it needs access to a 9, which would have to be then like that or like this. That is possible. Mm -hmm. Otherwise, it would be all part of this region. Because this cannot be part of that well, you could have 9 doing something like that. That is also possible. Hmm. Um, Interesting. Where is 8 in row 2? This can't be 5 because this digit must be greater than that one. It can't be 4 here anymore. So we have 6, 7, 8 here. Where is 8 again? 8 can't be here because of the thermometer. It can't be here because of 8 in the column. Can't be here because of the way that the thermometer works. So we're guaranteed an 8 in one of those two cells. That's interesting. We have 1, 2, 3, 4, 5, 7, 8. Um, 4 eliminates 4 here. Hmm. This could be red. It could be the same as yellow. It could be some other regions, so like blue. Uh, 3 of red have to be in column 1. So one of these has to be a 6. And 5. So we have to have 5 and 6 here in one of these 4 cells. So that eliminates 5 and 6 in the rest of the column, so this can't be 5 or 6. It's 3. That eliminates 3 in the rest of the row, so no 3 there. And row, no 5 or 6 either. So no 3 there. It's 4, 7, or 8. One of these then has to be a 3. We need light needs access to a 5. And the red 5 has to be one of these. 4 cells. So the light 5 cannot be in column 1. The light and can't be in this cell here. So where's the light 5? It has to be here. That eliminates 5 in the rest of the column and row, so this can't be 5, it's 6. That means no 5 or 6 in the rest of this row. So we have 7, 8 here, 1, 7, 1, 7, 8 as possibilities. So 6 for the light is going to have to be one of these 2 digits, which eliminates 6 in the rest of this row. So no 6 there. Um... 3 eliminates 3 in the rest of column 1, so no 3 there. 6 eliminates 6 in the rest of column 5. So now we for sure know that this can't be the same as this region here. Um, hmm. Where is the 9 in row 8? Cannot be here because of 9 in the region. Can't be any of these cells because of 9's in the column, so 9 has to be here. Which means this can't be 9 here. That should give us 8 9s. 1, 2, 3, 4, 5, 6, 7, 8. And we know where the last 9 has to be. It has to be there, which cannot be red because then that would be a duplicate in this column. So we now have the red region as a whole. It has to be these cells here. That's 8 cells plus this cell here. So this can't be light. That's done as a region. And We have 1, 2, 3, 4, 5, 6, 7, 8 light cells, so this cannot be medium. Therefore, this is light also. So it cannot be 1 or 2 here because of 1 or 2 in the region, so this makes that a 6. 6 cannot be here anymore, so this becomes a 7, 8 pair. This 7, 8 pair eliminates 7 and 8 in the rest of the column, so this is 4, 6 is a pair. 6 eliminates 6 here, so that's 2. This can't eliminates 2 there, so that's 1. And these must be different regions. So this is going to be, right now, blue. It must go that way. There's no 2 here because of 2 in the row. No 2 here because of 2 in the row. So these are all separate regions, definitely. Where is 2 in row 1? Can't be in the light region. We already have a 2. And we already have a 2 in each of these regions. So 2 has to be one of those 2 digits there. This needs access to a 9. So it has to have the same region as that. Because it cannot be accessing that 9 there. These could also be medium, though. We don't know. We have 1, 2, 3, 4. If it's not part of this region here, 1, 2, 3, 4, 5, 6, 7, 8. And then it cannot be part of that region because that would block the yellow region. And that's too small. So this must be part of the blue region. So it's 1, 2, 3, 4, 5. It has to be 6 here. 7, 8, 9. And that's done as a region. Yellow has to get... These have to be yellow because yellow has to go out. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's done as a region. No 1 here because of 1 in the row. No 7, 8 here because of 7, 8 in the region. So that's 2, which makes this 5, which makes that 3. Therefore, that makes that 2, which makes this a 1, to be smaller than that 2. 1 eliminates 1 here. This is 7, 8 as a pair, so this can't be 7. It's 1. So therefore, this must be a different region than the medium and the dark have to be, because this medium has a 1, and so does the dark. No more 3 here because of 3 in the row. 5 eliminates 5 in the rest of the yellow region, so that's 6, which means this can't be 6. It's 4, which eliminates 4 there, so it's 6. 6 eliminates 6 here, so it's 5. No more 5 in the column. No more 5 in the row. No more 4 in the row. 6 eliminates 6 in the rest of this column. We have a 7, 8 pair remaining in column 7, which eliminates 7, 8 in the rest of the column, so no 7, 8, no 7 there. No more 6 here because of 6 in the row. This becomes a 4, 5 pair, which eliminates 4, 5 in the rest of the row, so no 5 there. It's 7 or 8. This has to be going out this way. Medium, so medium cannot be the same region as dark. Which means medium cannot be all of these. That's only 8 cells. So it has to be part of this region because it can't be part of this 976 region. Therefore, this is a different region. We need 4 and 5 are already part of that region, so it can't be there. So this must be part of this region here. So that's done as a region, and we know this is dark. This has to go out this way. This cannot reach the 2 here, and it must access a 2, so it has to access that 2 there. So we have one of these is dark. We don't know which. Because we have 1, 2, 3, 4, 5, 6, 7, 8. So we have dark here, or orange, and the rest of this is orange. Okay. 6 eliminates 6 in the rest of this column. Um, 7 and 9 eliminates 7 and 9 in the rest of this row. Or region. We have a 2 here. So where is 7 in row 1? It has to be one of these 2 cells. We need a 3 in one of these dark cells, so it must be one of those 2. We have to have a 5 in one of these cells in row 5. Sorry, row 1 in the dark region. 7, 8 as a pair there. Let's mark these as letters. So we're going to mark this as A and B. This must be A as a 7 or 8, which makes this B, which makes that A. A and B there. Huh. A is in the orange region. So where is A in the dark region? It could be here, here, or one of these 2. Um... So we have a guaranteed 3 or 5 here. The last one is 4 or 8. So could be this 4. Oh, orange needs access to a 4. Well, it could be that one also. Ooh. Oh. We have a 5, 6, 8 triplet in the orange region, which eliminates 5, 6, 8 in the rest of the orange region. So this can't be 8. It's 7. That means A's are 7 and B's are 8. This can't be 7 or 8, so this must be 3. That eliminates 3 in the rest of the row and column. So this is 5 or 8. Where is the 3 in row 1? It has to be here. 5, 6, and 8 as a triplet. 7 eliminates 7 here in row 8. So this becomes a 6, 8 pair remaining in the red region. That eliminates 8 in the rest of the region, so this can't be 8. It's 7, which makes this not 7, so that's 8. 8 eliminates 8 here, so it's 5, which makes that 8. 5 eliminates 5 here, so it's 4. No 4 or 8 there. 7, no 7 or 8 there. It's 4, which makes this 8. So dark cannot contain another 4, so this is not dark, it's orange. This can't be orange then, so that's dark. And these are the regions. 8 eliminates 8 here, so it's 6 and 8. This can't be 6 or 8, it's 5, which leaves this as a 6. And 5 eliminates 5 here, so that's... Oh, we knew this had to be 4 and 5. Anyways. That's done. Only 3 slow thermos. So this was a slow thermo here. This was a slow thermo here. Where's... this was a third one here. There we go. Huh, I'm kind of confused. Why is the title then Four Slow Thermos? Anyways, that was kind of cool actually. It was interesting where things could be, right? So it used a lot of the geometry to restrict things. So, anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.